Thanks everyone for coming today. I'm Laura Filano, an associate professor here at the Institute of Design, and this is part of our Latham Fellows Lecture Series, which this year has focused on the intersection between ethics, emerging technologies, and design. And we've covered a wide range of topics this semester, including the implications of robotics and the future of work, Afrofuturism and media storytelling, smart cities and the politics and ethics around those technologies, and then today, design in the blockchain. So I'm really delighted to introduce our two speakers today. We have two speakers, Smiljana Antonijevic, author of Amongst Digital Humanists, and the two perspectives that we're bringing to this topic of blockchain include an anthropological or sociological viewpoint and a kind of computer science viewpoint. So Smiljana will be talking about the anthropological viewpoint based on some recent research she's been doing. In addition to her book, she's also appointed as a research fellow at the Integrative Research Center at the Field Museum, and also a senior research consultant in user research for the Newberry Library. And she has done qualitative research on a range of topics, including user-centered design and data curation and digital scholarly collaboration. And Carl Fogel, who's representing more of a computer science perspective on this topic, is an expert in open source software. He is a partner at Open Tech Strategies. And he's been active in the open source community since 1992. He wrote a book on producing open source software for the O'Reilly Media series. And he works with a number of technology companies, including Google, O'Reilly Media, Code for America, all related to open source consulting projects. And he's also has been also a fellow at the New America Foundation around issues of open internet tools. So with that, I'm going to invite first Carl's perspective on the topic of blockchain. Again, like representing more of a technical computer science perspective, and then next will be Smiljana's perspective, which will be a more anthropological take, and then we'll have a few facilitation questions, and then we'll take questions from you all. So thanks again for joining us. So Carl, I'll invite you to take the mic.
Thank you. That's the high point. I guess I'll sit down now. So I've been brought in as the tech cred, I think. I'm just going to, since I'm not a blockchain expert, I'm going to establish my credibility by showing you the stickers on my laptop. This is how you know there are actual Bitcoin on this laptop. But the hard drive is encrypted, so it won't do you any good. So, being a computer scientist, I have no visual sense, and therefore I've not got slides for you. I'm instead going to try to explain the basics of what blockchains are and how they work. One of the nice things about blockchains is that it does not actually require an understanding of deep mathematics to understand all the important stuff about how they work. There are some basic concepts. I will try to cover them here. I'm going to introduce some terms that may be new to some of you, probably not all. Not to Jack, for example. And hopefully I will define them well enough that if we use them later in the discussion, they will feel familiar and meaningful at that point. So one of the interesting things about blockchain is that, or blockchains in general, is that it is not a new technology in the sense that someone came up with a new technique or a new algorithm. It's a recombination of things that have been around for years. I was talking to Laura and Smiljana earlier, and they said that the analogy I like to use is, it's like the fax machine. Fax machines were famously a thing that could have been invented 20 or 25 years before they were invented, because all the things like the phone lines, printing, digital printing, analog signal processing, all that stuff existed. Just nobody thought of it. That was all. Like, you could have done it 20 years earlier. And when they finally did, they just established a standard, and suddenly fax machines sprang up all over the world, and they're only now disappearing. Blockchain is similar. So I'm going to give you a few of those components that themselves are quite venerable. They've been around for a long time, and they were not lying in a dustbin. They were being used for other things in computer science this whole time. And then a few years back, somebody sort of put them all together and came up with this idea of the blockchain. And then I'll talk a little bit about what blockchain does, and then I'll stop talking so that you catch your breath and actually hear something useful. So the first thing, the two most basic building blocks are what is called a checksum or a hash, and the other is digital signatures. Those two things are related. Checksums and hashes, that's the same thing. I'm using terms interchangeably. Let's just go with hash for now. That's a little bit more technically accurate. This is a wonderful idea that is something I'm glad that computer science is being introduced into the public school curriculum, because now everyone's going to understand this, and people like me won't have to get up and explain it every time. Suppose you have a document, a very long, multi-page book, and you want to know whether someone else has the exact same copy you have. How do you do that? Well, they can look at the top and see if it has the same author, name, and date, but how do you know that every last byte, every last character, every last page break and line break is exactly the same? Well, they could send you their copy, and you could then run a program that does a byte-by-byte comparison that matches up. Like byte number 1,000,003 is the same in each document all the way down to the end, or you know it's the same. Then that's long. You have to ship the document over. There's another way to do it, which is you take what's called a digital fingerprint, a hash, a checksum. And that is a wonderful formula, and I won't go into the math. It's not actually important. There are many different hash formulas, and just as long as you and your friend agree on which one you're using, it doesn't matter which one you use. What it is a thing that takes the entire document and produces a completely random string of, say, 48 characters. A, 3, B, Q, 1, 2, blah, 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 all the way to 48 of those, right? And the special property of these hashes, these formulas, these algorithms, is if you change just one letter in the original document, the thing that the fingerprint is being taken of, you will completely change the hash. It's not that, like, if the hash started out with A733Q, it's not like it'll now start with B733Q. No, it'll be completely different. Every last bit of the hash is going to look different. They're just mathematically sensitive. They're easily perturbed. So if you get the same hash document that someone else gets and you're using the same hash algorithm, that means that the chances are far, far greater that a cosmic ray has disturbed your CPU and caused it to miscalculate than that the documents are different. They are almost certainly the same. Like, the chances are way, way better than the standards we use for convicting people of the death penalty in court. It's really airtight, so don't worry. So, now you know what a hash is. It means that if you have a thing, you can summarize it in like 48 bytes or 32 bytes or whatever number you want, and you can prove that 48 bytes is a representation of whatever huge amount of text you want. It could be an arbitrary large document. Okay, now real quick, digital signatures. Digital signatures are a means of proving that you have attested to the authenticity of a document. They also can be used for encryption, for converting something to a secret and then decrypting it, but let's not cover that now. Those turn out to be kind of equivalent things. So suppose that I want to send you an email, and I want you to know for sure that it came from me in such a way that I can't even take it that way, that like I can't say, oh, I didn't send that. Someone can look at the signature and say, only you could possibly have signed this. The way you do that is with something called a digital signature, and I won't go into the math. It's there are a couple of numbers. There are different formulas for this. There are several systems. You can pick which one you use. It has to do with prime numbers. Basically, I have a secret number, which I never show anyone. And then I have a public number, which is related to that secret number according to a mathematical formula, usually involving prime numbers or a certain kind of geometry called elliptic curves. And then I publish the public number. It's like literally, I put it on YouTube. You go to my webpage and see my public number right now. And then if I want to sign the document, I publish the document and a little addendum, which is the digital signature, which I use my private key, my private number, to generate. The private number you can verify that only a person who has the mysterious private number could have produced a thing that matches this public number in signing a certain document. So now you know, like, if this person is, if we know this is their public key, then only they could have proven that they signed this document. Okay, now we can finally talk about blockchains, which are actually much easier once you know all that stuff. Blockchains are just a series of documents. For the sake of simplicity, we'll call each block in the chain, and like blockchain means what you think it does, a chain of blocks. Each block is a document, and each document is signed. And what is and hashed? It has a hash attesting to a certain fact about it. And what is that fact? The hash says, I am a digital fingerprint of this block plus this block before it plus this block before it. Goes all the way back to the root, the origin block. And that means that if somebody has put a block into the blockchain and they have signed a fact on that block, and they have attached a hash that hashes their signature, the block itself, and all the signed blocks previous to that, then basically you can know for sure that they have an entire copy of that blockchain, that they put something in, and that it was really them who did it. And the way that this is verified is that everyone is running the same code that knows how to insert new blocks, sign blocks, and do checks that blocks are fitting, that they verify according to the whole chain all the way down to the end. This means that you have to be running the software on your own computer, and you have to have a copy of the entire blockchain on your computer. So like the Bitcoin blockchain right now, it's around 200 gigabytes worth of data. It's growing all the time. There's one right there, if you want it. I'll bet Jack has one too on his computer. This is an interesting design issue, because as you start to use these blockchains more and they grow, not everyone can afford a computer that can hold the whole thing. 200 gigabytes, yeah, we can afford that now in the first world, but pretty soon it'll be a terabyte, and then we're right. Our hard drive's getting cheap enough, fast enough in order to store that. So that's a design issue. Now that you have the technical basics, I'm just going to cover a few of the reasons why this is important. One is obvious. Bitcoin is the first application of blockchains. It's money. That is, hey, what if we treat this whole series of blocks as a ledger where people have a certain amount of currency? And I won't talk about the mathematical mining process by which they get that currency, but just take it for granted that everyone, you can get a certain amount of Bitcoin either by just purchasing it or generating it through a difficult mathematical process. Once you have those Bitcoins, you can put transactions in the ledger. I transfer 0.2 Bitcoin from me to Smiljana. This is now part of the ledger. Smiljana, by the way, doesn't have to publish her real name. I'm just transferring it to her digital identity. So if nobody knows that that ID is, that digital signature is connected to Smiljana Antonijevic particularly, then they don't know who received the Bitcoin, but they can see that somebody did. And in fact, de-anonymizing people on the blockchain is a fun exercise that has been, you can look it up. There are lots of journalistic exercises in doing this. One of the most famous cases is the originator of Bitcoin herself. We don't know anything about this person, at least not definitively, but we do know that they're holding like $100 million worth of Bitcoin right now, and we sure wonder who that person is. But you can also use it for other reasons. One is smart contracts, and I'm just going to read a nice definition of smart contract that I got from the person who invented the term. A smart contract is a set of promises specified in digital form, including protocols within which the parties perform these promises. In other words, remember I said there's software running on each person's computer. If you're all running the same software, and the software agrees to interpret a certain contract language, which is think of it like legal language to the max, like a programming language, where all of the definitions and terms are specified completely unambiguously. So now you can have a contract. Suppose your blockchain has both money, some kind of Bitcoin or Ethereum coin or some coin that exists on that blockchain that everyone agrees on. And it has smart contracts. Now you can do an interesting thing. You can, for example, avoid escrow situations. Like if I want to gain title to a building and I want to transfer $1 million to a person in order to get that title, in the real world, you've got all these lawyers and people in a room and intermediaries and title insurance, right? And the reason is you've got this problem where a person signs over the $1 million, but then maybe the counterparty vanishes and they don't give you the building. Or maybe they give you the building and then you vanish, but you get the title, but you haven't transferred the $1 million. We have all this infrastructure to avoid that situation in escrow situations. We have escrow situations to avoid that situation. On a blockchain, you can write a smart contract that does those things simultaneously. In other words, the program, the code for the contract says, in one atomic unit, I agree that if the following conditions are met, you may transfer $1 million worth of this coin to so-and-so, assuming that in that action, they transfer this title, which indicates legal ownership of that building to me. And boom, there's no need for escrow, there's no need for anything else. In theory, there's no need for lawyers. Now, I'm presenting a very idealistic view of this. The whole dream of the smart contracts world is almost post-human, it's transhumanist. It's like, let's get rid of all the legal structures. There's a wonderful story about what happened when one of the largest blockchains, the Ethereum chain, tried to do this in a large distributed contract with many parties, which we may get to later in the sort of panel group discussion. But it turns out that when you remove all the human elements and you just run on smart contracts, if your contract code has bugs, you're going to go running and screaming for humans to make it fair again. And it's very good that we learned that lesson early on in the blockchain universe, I think. So I think I've covered all the important stuff. There are other applications, voting, multi-party lotteries, lots of things you can do with smart contracts. But I'd rather get to the interesting things, which is how can you use this? What are the sociological implications, the design implications? And so I'll stop there. If I have to introduce new jargon later, I will try to do some jumping.
Thank you. Okay, and with that, I'm going to just pull up the presentation. Let's try again. Okay, great. So with that, I'd like to invite Smiljana up to give us a sociological and anthropological view of this issue.
Thank you, Laura. Does it bring lights?
Yeah.
I can hear you.
Okay. And thank you, Carl, for this really great introduction to blockchain, so that we do not have to start every talk with blockchains. Okay, so I will try to talk briefly about design and trust in a cryptographic operation, and I would like to start with a quote from one designer who says trust will become perhaps the most important design element in any system. Maybe that has already been the case, but with blockchain and with all the recent cases of data breaches and things like that, we are getting to understand to what extent trust and design for trust is becoming important. Now also on one quote, this time from a person who was a respondent in my study, a study that I just completed that we'll talk about here briefly. It's the president of that Palgrave organization who says, so he's describing their cryptographic operation and says it's a technical process that could be done in software, automated completely, but then it would be vulnerable to all the same attacks. And software always is. And that's something that I would like you to keep in mind. So what is it, which elements are needed to design a secure cryptographic operation? So we could assume that simply having a robust software and good mathematics behind it, as Paul just described, would be almost enough. And we could then get rid of that really problematic element, which is humans. Carl, I guess, can talk about that humans are usually considered the weakest link in every security operation. And whatever goes wrong, it's not because it was designed badly or because anything went wrong on that programming side. It's because the users are not using it in the way that it should. So you could say that, with blockchain and with smart algorithms and things like that, you could get rid of humans. But is that really the case? I actually want to argue that it is not the case, and that we need this combination of technical, physical, and social elements that all come together in an interconnected way to actually build a really secure operation. And then we'll just go quickly through this case study of Packet Clearing House, which is a company in Berkeley, in California, and their domain name system security extensions key signing ceremony operation that I studied over the past year, and that I actually continue studying next to with ICANN, which is, as you probably know, laboratory for free. So basically, before that, let's see briefly what is the domain name system. You could say one easy way to describe DNS is that it is like an internet phone book. So, you want to look up your phone book, Smiljana. Oh, okay, so here is my number. You want to look up Carl. Okay, here is Carl's phone number. What can happen with that, however, is that someone like Carl, with his technical abilities, could actually take control over this internet Facebook and put his phone number as an iPhone number. So you're calling, and instead of hearing my beautiful voice, you get with your Carl. So what DNS is doing, DNS actually translates this, what we as humans can remember, smiljana.org, all those web addresses, into numbers, or translates numbers into this, which we can. So when computers communicate, they do not use this, what we are using. They're using all these numbers. So that's basically what DNS is doing. So again, here we have Carl, who wants to redirect you from my website that you're trying to access to his website by hacking the DNS and redirecting you. So you can assume this is just one simple example here, but just try to imagine that you're trying to reach a bank and that you end up on a completely fake website, or where someone is actually getting your password information and other critical information for that, or you're trying to access your health records or anything like that. So that's a critical part of internet infrastructure. So DNSSEC, DNS security, is basically a set of records and protocols for securing that really important DNS data. DNS data, which is secured through DNSSEC, is cryptographically signed, as I was talking about, which basically means that DNSSEC verifies authenticity and integrity of the DNS data. It does not encrypt it, but guarantees, and this is what I've been observing is root key signing, so it basically goes all the way to the root of the operation and traces that chain of trust. In a key signing operation, that's basically a cryptographic procedure in which a unique pair of digital keys or certificates is being generated. So now those keys, which are really critically important, where do you think are they held, or what is happening with them? Here we get to this physical set of elements and something that is called hardware security module. These are all 5 interconnected layers of security. So basically those cryptographic keys, and this is, you see the key here, but you would actually never see it outside the key and you would always see it inside. because hardware security module is a device that basically generates and stores those keys in a really secure way. I will explain what is the process of operating that. So now look at this. HSM is always stored in a tamper-evident bag. Close. HSM in a tamper-evident bag is always stored in an enclosure which meets the Central Intelligence Director's directive for secure handling of classified information. So that enclosure is stored in a hard environment, which basically is, which cannot be opened in any way, which is not recorded under the camera's log and so on. So all of this is stored in a facility, key signing facility, which has strictly controlled access and, again, cameras and logins for every time someone gets in or gets out and so on. So all this is basically happening so that Carl could not redirect you to his website. That's where we covered that physical part. HSM, which I already mentioned, is at the same time part of that key technological set of elements which are used in a key signing operation. HSM, as I already explained, is used to generate and store the keys. Now, what we need to actually operate the HSM, to unlock it and to operate it, is smart cards. So, HSM cannot work without smart cards. And then, in a key signing operation, we also need a laptop to which HSM is connected, which, important to keep in mind, is without hard disk. Why is it important? So the data cannot be stored in any way, and the keys cannot actually leave HSM. And just to add to that, also keep in mind that each of these elements is again stored in a tamper-evident bag, and we'll talk about it. Now, social aspects of that entire operation. First, we have something that is called persons in trusted roles. It's basically security controllers and crypto officers. These are, they are called people in trusted roles because they have that really crucial function, and what they have access to and what they can do can actually really influence that process of generating and using keys. So that's why their roles are extremely important. Now, what is also important is that these roles can never be held by one person at the same time. And the division of those roles is very strictly enforced. Why it is important? Because crypto officers have smart cards. Each crypto officer has one smart card, and those smart cards are needed to operate HSM. They, crypto officers, can never have access to HSM, so that they could not misuse this access to smart cards that they have. At the same time, security controllers who do have access to HSM can never have access to smart cards. So that although we have that trusted technology, we have people whom we trust and who have been selected as very trustworthy individuals, we still do not trust them enough. So we always keep that completely separate. And as I mentioned, to add on top of that, I think each of these is also called in tamper-evident bag, as I previously mentioned. So tamper-evident bag actually brings us to this interesting other set of people, which are called people, other authorized people or people in authorized roles. So one is an external witness. Every time in a key signing operation, we want to take out from all those enclosures and so on, we want to take out a laptop or an HSM, we take it out, security controller takes it out of the tamper-evident bag and always reads the number of the bag and the number of the machine. external witness who is provided by a law firm has to testify that it is the same serial number that was recorded in the previous operation when it was closed, temporarily and back. If the external witness does not testify to that, the operation has to be cancelled. It cannot go on. So just think again, layer after layer after layer, person after person of basically people controlling each other and what they're doing. Another is ceremony administrator, a person who is actually executing the whole thing, who operates on the computer and the HSM generates keys and so on, develops that entire script. Facility operator, also very important person who actually gets people into the facility, secure facility, takes their IDs and so on. And this is also important, a facility operator who ensures that before the ceremony starts, before anyone gets into the key signing room, that all the audio and video equipment like we have here is turned on. The room in which the ceremony is taking place has 3 cameras or 4 from different angles, so that every single element of the ceremony is recorded, and all those recordings are uploaded to the internet, so that everyone in the world can see every single element again that was happening in the ceremony, from the moment before they start entering the room to the moment that they exit the room. And there are representatives, so basically this is an operation that serves each and every of us. We are all, you could say, clients of this company and this operation. So any of us can actually apply and go and say, I want just to be a representative to see how this is being done. You will then get a big list for correct officers. I had one with R, because I was a representative or a researcher. So basically, again, you have this entire, different physical, technological, social elements involved that are all controlling each other, as I already explained. So just to run quickly through some things about UX design for blockchain. Again, one quote from Fleming last year: when using the product built on blockchain, most users want to understand the underlying protocol. Fortunately, they don't need it. Instead, they need to learn to trust the trustless technology. I don't know about you, I actually have a problem with statements like this, that we do not actually need to understand what is happening there, we just need to trust that technology. So, a lot of discussion actually in the user experience and design fields about blockchain and designing for blockchain and how can we deal with user experience related to blockchain and so on. A lot of discussions about that. Here is a set of something that I would call maybe debatable practices of design for trust. One is transparency. So transparency, in the previous example that I gave you, is extremely important, but one of the elements is that you can really see everything through those audio, video recordings, the ceremony script is available online. So literally everything is available to you. No one says like, oh, these are the elements that you could actually use, and these are the elements that are too complicated and you cannot understand, and so on. What we have here is like, okay, this was a nice quote that I, since I'm running the time, do not need to read. But it's basically like, if you are seeing that hash that Carl was talking about, you will not understand, but it somehow makes you feel secure. It gives you what we call in data ethnography, like comforts of the data comforts. Consistent terminology, visual consistency. I mean, honestly, I do not think that just having color meaning and things like that is something that will design for trust and convey trust to people. So anyway, a set of best practices that I actually thought were really well formulated. One thing is that, as Carl also mentioned, when thinking about user experience and design, we should keep in mind that extra attention should be needed, since user actions are irreversible with blockchain. So that we should always add that layer of like, are you sure you want to do that, and things like that. Also, I would say that presenting user with a new vocabulary, with tips how to use certain tools and so on would be a good idea. So instead of trying to make it like, oh, you do not need to understand it, no, let's help our users try to really understand what is happening. Designing across borders, blockchain is distributed, and that's basically, those were some. I just wanted to go briefly through this and to open the floor to our discussion about how we can design and develop user experience for trust and blockchain. So thank you. If you have any questions, please.
So we will rearrange the chairs here so that we can have more of a discussion. Great. Yeah, come on up. No, I think it's better if you guys on the center. So one of the things that I think is so okay. So one of the things I think is really interesting, especially on that closing thought, I think we can relate it clearly to the current situation that we're in with Facebook and social media and Cambridge Analytica. What's really interesting about some of the debates that are happening now and some of the concerns that are being raised both in technical and in sort of sociological takes on these issues are similar to the kinds of debates that were happening over 20 years ago in a very nascent moment of the internet. There were lots of communities that were formed, like Computers for Social Responsibility, and a lot of privacy organizations, and a lot of sociologists that were studying all of these issues, but looking at earlier technologies. And so what I think is fascinating about our focus this year on emerging technology is the ways in which, following some of these issues that are happening right now with the blockchain, allow us to potentially understand implications of emerging technology that are throughout the economy and throughout society as well. So I wanted to, so with that in mind, perhaps on this point that Smiljana made, that the previous few decades even were about the fact that users don't need to understand the implications of the technologies they're using, and then Smiljana's argument that actually we do need to understand, and then Carl's emphasis on ways of communicating some technical things to broader audiences. And I wondered if we could start with that tension between users not needing to understand and then understanding.
Well, yeah, I think that's a really good place to start. I want to, I promise you, I'm not just saying this because my professional specialty happens to be open source software. I think this is actually an important dichotomy in software in general. There are a number of programs that you run that are probably not on your side. They don't want you to understand what is going on with their code. And I include, for example, virtually all of the code running in your web browser that is controlled and sent to you by Facebook. So when you visit Facebook.com, your web browser basically gets some code from Facebook and agrees to run it within certain security constraints in your browser tab. All of that code is designed to serve Facebook, right? And a good general distinction between code that has at least the potential to not be serving you, even though you are the user, and code that, in some sense, has to be serving you, is whether or not the code is open source. Can you see it? That doesn't mean that you have to be a programmer. What it means is that you have the potential to make an increasing investment in understanding the code, and that investment will be rewarded at a linearly increasing rate. The more effort you put into understanding, which could include bringing in a consultant or a friend who does programming or whatever, the more understanding of what's going on you will get, and that there will be a comprehensible and predictable ratio between that investment and the reward. When I was listening to Smiljana talk about how to design systems to be trustworthy and to appear trustworthy, I also thought about how to design systems that appear deceptively to be trustworthy. They make you think they're trustworthy, and in fact they're not. And what I kept coming back to was the reason I like to write open source code is that if it were doing something untrustworthy, either I or somebody else would have spotted it by now. Now, that doesn't mean there aren't bugs. There are sometimes. But in general, if that code is trying to do something malicious, people will just say, well, let's fix that part, because it shouldn't be doing that, and they can see the actual software source code and fix it. This idea that you should have not just the expectation, but even perhaps the right to make that investment and get a proportional reward for it in understanding is something that has really been lost as software has become more and more a part of our lives. It's embedded in all our devices. It's not just your web browser, it's your toaster, it's your car, right? It's your shower head. I mean, all these things have chips now. And the idea that the software running on them should serve you and should be inspectable for trustworthiness and worthiness in general is slowly being lost, and that worries me a lot.
I mean, as a user and then also as a researcher of digital culture and communication, and most recently as a person who is on the design and user experience side, I've been thinking about that, of course, for a number of years, and trying to argue that we do need to understand technology. I don't know how is it that you as a researcher, not to say as a user, but let's say as a researcher, you're studying Facebook, you're studying social relations online, you're studying digital identity, communities, whatever, and you do not actually understand how it functions. How then can your study be trustworthy? How can it be relevant when you do not really know what is happening behind and what are the algorithmic decisions that are being made? So you interpret it as something that people are doing online, that users are doing, while actually it's the algorithm which is acting on their behalf, for example. So something that you would absolutely need to understand as a user, as a researcher, as a designer. I think that some of those readings that I wanted to quote here about design and blockchain, it seems to me that a lot of writing actually comes from designers not knowing what blockchain is. So they're just writing, well, okay, this is how it seems to me, and this is how it seems to me we should do this. But it is really critically important to put some effort and to understand that technology and what is behind it, I think, for all of us. That's great.
Another question I think is really interesting is thinking about blockchain with respect to business model innovation. A lot of designers are going to be in the business of figuring out what a particular strategy for a business to take. I wondered if we could talk about some examples of where the implications might be in terms of new business models.
We'll just go. Emanating from Laura each time. Well, I think this is where I get to tell that story about what happened on the Ethereum blockchain. Because it was wild. How to summarize this I don't want to ever be presenting analogies as the actual thing, but on the other hand, there's a limit to our amount of time. But basically what happened is a group of people got together on the Ethereum blockchain and they called themselves the DAO, D-A-O, Distributed Autonomous Organization, I think is what it stood for. If anyone has a correction, please just shout out. I don't want to be giving this information. Or at least I don't want to get caught at it. And the idea was that they were going to write a smart contract that would enable them to vote on where to direct this money. And I think the goal was going to be they didn't know where it was going to go, because it was like if you were a member of the DAO, you were committing a certain number of your Ethereum coin, Litecoin, or whatever it's called, to this group collective project, and no one knew where the voting would take it, but I think the general understanding was some sort of philanthropic endeavor. We'll never know, because what happened was some clever people found a bug in the contract that let them, at a certain rate, not all at once, but at a certain steady rate, start draining money out of the distributed autonomous organization and into their own account. Now, nobody knew who this person was, But if your currency is to retain its legitimacy, you can't just like cancel those dollars. It's like you know, when somebody steals cash, the federal government doesn't cancel the serial numbers on those bills, right? Like it's understood that if the cash circulates, even though it was known to have been stolen at one point, it is still legitimate cash. The person or persons who started this drain going, they got like I think it was like $30 million or $50 million worth. It was quite a bit. But the total amount available for that drain was like 180 million. And while this was going on, it was, by the way, it's blockchain, it's transparent. Everyone could see it happening. And they're like, well, what do we do? I mean, the contract is already there. It's locked in, right? We agreed to abide by the terms of this contract. And the person who they thought of as a thief, or some of them thought of it that way, that person, whoever it is, started posting. You could verify the post, sort of, because there was a digital signature, though it turned out it was not quite reliable. Complication, don't worry about it. But the person said, I think that you're all going against the terms of the contract we agreed to. We said we were going to abide by this contract. This contract lets me drain everything to my account. So that's what we're doing, right? So a bunch of other people who felt that this wasn't the way things should be figured out what the bug was, and they quickly exploited the same bug to drain the remaining coins out to their own account with the intention of returning it to the rightful owners when all was done. And they successfully did that for the majority of the money. Meanwhile, the whole Ethereum community, more or less, got together. And remember, if you get a majority of the copies that are called nodes of a blockchain, the people running the blockchain code who have a copy of the chain, together, and they vote on something, like they can make it be true because blockchains are designed to operate on a consensus basis. And you get 50% plus one of all the available votes, then you can change the rules. And they decided to change the rules on the smart contract, and so the whole thing got canceled, and that was the end of that. Everybody, I guess, got their money back. I think maybe there was a little spillage one way or the other. So I may be fudging some aspects of that story, but basically, they designed a contract. They did not anticipate bugs. They certainly did not anticipate that someone would look at the bug and say, well, that's just part of the contract. You wrote it in the language. This is very similar to a recent court case where, if you remember, there was whether the Oxford comma in a trucking industry contract or law meant that certain trucking companies or truckers had to pay a certain amount of money or didn't have to. And the question was, what is the literal meaning of the contract or the law, and then it was a law, and then what was the intended meaning? And the question of which of those two should govern if they could both be discovered was actually up and at argument in court. And I think it was very similar to what happened. And in both cases, in the end, it was a kind of human sense of judgment and fairness that governed what finally happened. I think that story holds wonderful design implications for blockchains and technology in general. Like you can make your system do anything, but if everyone who's using it thinks it's wrong, they're going to work around it or find some way to change it.
About those future developments, it actually reminds me of what after the first WikiLeaks craze, what Umberto Eco said, talking about that we will start going backwards when we see what technology can do and how we cannot always control it, and that it can have some consequences that are not acceptable for us, that we will report to. You might know there was that famous case of Osama bin Laden, who, so whatever information he was transferring with his people, it never left hands of really trusted people. So it was never even close to any computer network or anything like that. And it is interesting to me to look at these people from PCH, for example, and ICANN. So those are people who are dealing with critical internet infrastructure. All of them really top experts in security, in cryptography, and so on. Really devoted and dedicated to online security and things like that. Thinking carefully about how it can be done and going with all those operations that I described. So, it is often, suggested that we as users, you should just trust technology, you should be fine. But they, as people who are actually really dealing with that, do not trust it. So they are using temporary evidence bags and enclosures and facilities and things like that, and external witnesses and so on. So there is something to really think about.
Actually, can I add something to that? Just another example of what Smiljana is talking about is if you follow voting technology debates, one of the patterns you notice right away is that all of the people who have the most technical expertise and have studied the issue the longest have all consensus on the same conclusion, which is, okay, if you want to use digital, like graphical user interface is fine, but there must be a paper trail that can be verified by the voter and put in storage and hand counted by humans. The only safe technology is something with a paper trail that can be subject to a manual recount. And like this is, as far as I can tell, a unanimous conclusion across every expert that I would take seriously in that debate. So they all basically shy away from fully trusting the technological solution when it comes to something that's important.
And I think earlier, when we were prepping for the panel, you had raised an example in the health industry about whether or not one might want to adopt blockchain versus all the other kinds of ways of verifying. And I wondered if you could share that example as well.
Sure, yeah. Real quick, one of the things that you've probably noticed if you're even looking at headlines is blockchain is become a craze now. Every company is spinning up their own special blockchain with their own coin analogous to Bitcoin. And proposing to run lots of applications, contracts or data storage, with irrevocability and verifiability and all that on the blockchains, often in cases where we've already had good solutions that don't involve all the complications and the overhead of a blockchain. So one example is, like, if you, suppose that it becomes important to determine that you had a certain medical record about you or someone was true at a certain time. This comes up all the time for insurance purposes, for court testimony, knowing someone had a certain condition in a certain way in a certain period of time, etc. One way is you can have the doctors publish to a blockchain a digital signature with with a statement that so-and-so, maybe they're identified by a secret code to preserve privacy, had a certain condition, and then everyone in the world has a copy of this blockchain on their computer. It's constantly growing. Like, yeah, this satisfies a certain theoretical information security property, but in practice, how do we verify these things? Well, when you really need to know whether something was true, you make an investment in verifying it, and that means that you ask the patient, you ask the doctor, you look at the doctor's emails, you talk to the nurse, you go look at the paper file where the doctor kept their notes, you do a bunch of things, and those things taken together, as with the tamper evident bags and all of the security dams that is physically being done, those things together are much more convincing than a record with a secure hash in a blockchain somewhere, because it's actually much easier to compromise that hash. Like if you give me the task of, if you said to me, you have $1 million in 6 weeks, go get access to someone's private key so that you can publish medical facts about them in a way that looks like it came from them, I'd give myself a 50-50 chance. I'm not saying I can guarantee it, but probably I can make it happen. But if you said, here's $1 million in 6 weeks, go make it so that this medical fact is true and that will, everywhere we look in the hospital system, the doctor's records, all over the place, we will not find any countervailing evidence. I don't think I can do that. It's the complex human interacting systems with redundant data in multiple formats, in particular analog formats, that are really secure. And the thing is, they just require a little bit more investment to do the verification step. But in terms of information security, I think they're a lot better. Is that where you?
Absolutely, that's super interesting. So I think there are lots of really interesting intersections with design, and I do want to open it up to the floor for questions. But I would suggest a couple of broad areas that are interesting. One is looking at blockchain vis-a-vis the history of innovation, the ways that it is formed from existing things, and the example you gave was the fax machine, and in what ways are design capabilities similar to those kinds of ways of bringing different ways of assembling existing things into new innovations. Another really, I think, does get at this issue around openness and transparency, and the issue the design field has around intellectual property. Much of the knowledge that's being created in the design field is happening within private companies or private consultancies that are doing things for clients, and that has actually prevented us to some extent from really publishing a wider, building a knowledge base in the field. So we could look a little bit about, open source and transparency and how that plays out also in the design field. But I'll just throw those out as examples of things that we might discuss. But I would like to now invite everyone for your questions as well.
Okay, hi everyone, I'm Becky. Okay, so I'm going to quote my own Facebook. And I posted this on March 20th. I think this is like when the Cambridge Analytica started blowing up. And I wrote, we should all revolt and claim Facebook as our democratic socialist nation state. Basically, the story that you told, Carl, about the Ethereum blockchain, people kind of like, community organizing and coming to a consensus that the terms of this contract should change and acting on the system, right, reminds me of that joke that I made. And I'm just curious to hear what, my mind immediately goes to things like community organizing and like unionizing as consumers of these products and these like spaces that we inhabit on the internet. I don't know, I'm just curious, I don't have a specific action, but question, but like, I've said those words, now you say words.
Well said.
The question was for you, but I can just talk. Yes. While you were saying that, what came to my mind right away was now late John Perry Barlow and, the Declaration of Independence of the Internet.
Mm-hmm.
So that was at a time when the Internet was still new. Those were the expectations that we had. Like, this is going to be our home, and all those companies and governments will have no authority here, yes. We see how true that is. So, that's something we had those, I would say, really positive utopian ideas throughout the entire history of the Internet and technological development and so on. But I assume that they are simply too important to be left to us.
And I would actually want to say that, no, that we did build that utopia, and it still exists. And it exists alongside the proprietary, commercialized, user is product universe of Facebook and a lot of these other companies. It never went away. In fact, it's still growing. And actually, there are decentralized, user-friendly, user-controlled social media networks, Mastodon, Blue Social, a few others, that are meant to do what Facebook does, but in a way that serves the users rather than Facebook's advertisers, Facebook's customers, I should say, right? Famous formulas that the users are the product and the customers are the companies that pay Facebook for data. So all of those things exist. They have not proven as attractive to people as Facebook, statistically speaking. Most people are not on. You might be an exception, but...
No.
Okay. You didn't say you wrote that on Facebook.
Yep, I wrote it on Facebook.
I mean, maybe this is just congenital optimism, but I do. The way I see the internet working is that you get venture capital funding, which always goes into proprietary things that can be, if they succeed, will succeed massively and get hundreds of millions of users, and there'll be what VCs call the hockey stick curve. You invest, the company loses money for a while, and then it suddenly starts catching users, and then it goes off to infinity, and you make $1 billion. Right? While they're doing that, while the VCs are putting money in all these different things, the free software world, the open source world, is sitting back. It doesn't have a lot of money. It has some. It's not totally broke, but it's not like VC money. It's watching and it's seeing what works. And the things that really take off, we're letting the VCs do the experimentation, right? And the things that take off, we start implementing as open source. Pretty soon, every important subsystem of the internet either starts out as or gets implemented, gets commoditized and gets implemented as open source software. So I feel like, wait 10 years and the Facebook that you have today, you will have in a decentralized user-controlled way, but there will be some other thing that everyone's on that will be run by VCs. So if you don't mind living 10 years in the past, you can join us.
So one of the big problems with Cambridge Analytica and kind of some of the other things that happened recently is the things will not be deleted, and that there isn't an ability to forget or remove them. And with blockchain, it seems like one of the key features is the fact that all history remains forever. It doesn't seem, I've talked to some people about like collapsing early history or things like that, where you can try to remove some history from blockchain, but going forward in like the future of technology and the future of our governments and things like that, is it a good thing to put systems of payment and completely immutable? We can look at like what your great grandfather spent on something. I mean, like, are there social problems with not having blockchain and not having the ability to forget?
What a great question. Yeah. I worry about that all the time. I mean, it's not just, like, that's not really a blockchain problem. That's we've all had the thought of, like, you know, I think we're mostly the generation where the foolish things we did in middle school and high school are not recorded for all time on the internet because, or at least not on the World Wide Web because there wasn't a web. But for the generation currently in middle school, that's not true. All the foolish things they did will be reserved for all time. And some people have said, well, that will lead to a greater acceptance of people's foolishness, which may be partly true. But also it's just kind of a tragedy that a kind of space for reinvention that was part of the human birthright for all these thousands of generations is suddenly gone. Like now there's a permanent record for the first time in human history. And we have no idea psychologically or socially what that means. But I know that I really am glad that I don't have it. and probably, like, I see other people nodding, and the older, the more gray hair, the more nod I see. So, yeah.
I'm actually not so sure about that. I'm not sure that if the entire world's wedding videos were posted online, that at a certain point you'd stop watching wedding videos. I think there would be a ceiling effect where everyone's stupid stuff would be online that nobody would care.
Well, like, so for example, when Sarah Palin was running for vice president, she was a young person in the age of video, not the internet. And there's a recording of her doing a flute solo at some beauty competition or something, where she really messes up. And she handles it well, I have to say, but she just totally forgets the notes and kind of makes stuff up and drops off at the end. It's not that everyone is going to want to watch all the wedding videos, but if you are being appointed to the Federal Circuit Court, if you're running for office, if you're being interviewed by someone for a particularly prominent job, they will hire an investigator to dig up this stuff and find out aspects of your character that may no longer be true. Where does your ability to control self-presentation and someone else's ability to find out the full history of your psychological development begin? I guess is the question. When they have an interest and will make an investment.
Just on that.
Yeah.
But that happens now.
Right.
Meaning there's nothing that's stopping anyone from getting that information. Politicians get outed all the time for things that have been previously done. With enough, like you would say, with enough time, energy, resources, you can kind of track everything.
Well, a lot of the data is gone. Like back in the day, just a lot of facts about, I know that a lot of facts about my middle school and high school career just don't exist, except in my memory. There's no one you can consult to get them, but I think that with Facebook recording everything and surveillance videos of everything, I just think there's just more data to work with. There's more for the investigators to turn on. I think, sir, that you had your hand up. And so, yeah, okay, I'll stop talking.
Just to think about that for a second. 150 years ago, when we all lived in small towns, except for big cities, so those small towns had all the memory.
Yeah.
And what they developed and what they still have, I live in a small town of 2,500 people across the lake. What we have developed is we ignore certain things on purpose to get along, because not getting along is much worse. And so, as we ignore some things about our president already, not so good, I think, but in a small town that works, but it's also it dumbs things down. I have a question. I work in real estate, and I do digital signatures. And as far as I'm concerned, they were shipped because the only thing that verifies it is an email address. And yet we use it all the time, and it works. So my question is, do we have to have absolute confidence in the system to use it effectively?
I want to leave the big part of your question for Smiljana, but I do want to say something about the terminology. The thing that you are calling a digital signature is not the same thing that I was calling.
Right, you're right.
Like, you know that, okay.
Mine's a fake.
Yeah, basically, they took,
every day.
Yeah, the real estate industry and some other industries took our good brand and they called something, they diluted it, and called something else that thing that was trustworthy. And those digital signatures, yeah, I agree, they're worthless. But they're not cryptographic signatures.
But I do $1 million transactions on them.
Yeah. Smiljana, why don't you take that one?
No, it is interesting. I actually had a conversation with someone last evening about who said, well, blockchain is really secure and trustworthy because people have so much money in there. And I said, well, it doesn't mean that the system is secure. It just means that people perceive it to be secure, just like with your digital signatures. So you somehow all agree that that's the way to make your work more efficient and so on. Is it really secure? I doubt.
That happens all the time.
Yeah, that happens all the time. And in terms of memory, I think that that was a really good question also about and all those comments about what is it that we forget, and as we know, the Right to Be Forgotten initiative and our friends from the Internet Archive who are getting requests on a daily basis. Can you please remove from the archive whatever is there? But then think about, on the other hand, deep fake, for example. Deep fakes, which are developing on a really crazy scale. And basically, you can now create like anyone said anything with video materials, audio materials, and so on. So we will need something to simply counter that kind of absolute. I think that videos are not even acceptable in court anymore, because the level to which you can fake what is in the video has become so sophisticated that it's simply useless as any kind of evidence. So just think about that and the value that something that has been recorded as it was will have.
I just wanted to add one footnote on this forgetting conversation, because I think an important part that's come out over the last number of weeks with these lectures is that the implications are going to be different depending on the power and the position of the person, and that includes, race, class, gender, sexuality, disability, right? So if you're a politician and someone digs up that embarrassing video, it might have implications for you. But if you're a fast food worker and someone digs up a video, that might also have implications, and they might be more severe for you because you have no other way of getting a job, whereas someone who has more means might have better, networks that can allow them to then still gain social mobility or get elected or whatever it is.
That reminds, sorry, I have the microphone, so I'm talking into it.
Jump in.
That reminds me of this one case, which I don't know, in my social media, I definitely heard of this multiple times, but I don't know about everybody else here. There is a case of this man who's running for some local politician role in West Hollywood in LA, the gayborhood of LA. And he is gay, and he is on dating websites where he has nudes, and he, as part of his campaign, released the link of the collection of nudes that he uses on his dating websites to be transparent, to get ahead of any kind of expose or any kind of power move based on that, which I think speaks to what Laura just said. We're okay, in the gay man community, or in some gay man communities, these nudes would be they wouldn't be an expose, it would be a power move to say ooh, I'm confident in this way, and this is who I am, and this is my community, and this is my culture. So yeah, I just thought that was an interesting case.
I agree, by the way. Let us know if he wins.
Yeah.
So this question is about kind of bringing it back to trust in social institutions. It seems like a lot of the hype around blockchain was in its ability to disrupt institutions and the decentralizing aspect of it. Yet at the same time, we realize that we need social institutions because that's where we put a lot of our trust when we don't understand things. So for example, like we don't need banks, but we do need the New York Times. And we want to know where the information comes from. So I'm wondering if you could comment on which social institutions you think we need and or could be supported by blockchain and which ones maybe need to be disrupted.
Wow. I did a lot of, as part of the papers here, it's like all the kind of reading on blockchain that I was doing before coming here, and I thought I'd hit all the interesting questions. Like every question and point coming out in this discussion is something that I did not encounter, didn't think of that. Yeah, I mean, I do have a little bit of a techno-utopias feeling that like some of these institutions, like, do I really need real estate title trust companies? Like, is that just a parasitic thing that is, it's serving a real purpose. It's solving a problem of wanting to be very sure about who owns particularly expensive objects that can't be moved, right? But if there were another way to solve that, I'd be okay with them disappearing. People will lose jobs, but that's not a good reason to have a parasitic structure in your society. But is there anything that even just taking blockchain particularly, that it can really fully replace? Like, even in a title trust company, it's just any cryptographic system. Here's the dynamic. Here I realize now the sort of big picture of what I'm getting at. If you have a system that's fully automated, that replaces some human institution that is currently valuable to us, if that institution is valuable, it's because it's serving some purpose that has significance in our lives. And if there's an automated system that's doing that instead, by definition, learning how to fake and subvert that automated system will be valuable, because otherwise we wouldn't have cared about the institution that replaces in the first place. And it's always the way computers work. If you can subvert it for one person, it's usually easy to replicate it to subvert any people, as many people as you want. And that's a lot harder to do within an institution, precisely because they're less efficient. I don't know how to go and masquerade as a dozen different purchasers to a title company. Like, that's just a lot of sunglasses and fake mustaches that I have to change quickly, right? I do know how to do it on a blockchain. I mean, if I can figure out a bug in that blockchain, I can replicate that all over. So I think institutions are necessary because they're human and inefficient. And I can't think of one that I would really confidently eliminate in favor of some automated blockchain-based thing. I can see blockchain being an adjunct to that. Did you want to say something?
I think that it is also, it reminds me of that old question that we all had as students, what is this, are guns killing people or are people killing people? So something around that. So which institutions? That's really a good question, because I'm thinking like, okay, so you can think about the Library of Congress, which is supposed to preserve everything that is relevant for the society and so on, which decided not to archive tweets anymore. You can assume why could that be the case. So now, on the other hand, you have an institution of Internet Archive, which is absolutely preserving everything, including all of his tweets and everything that is, around. So it is not about the technology itself, it is about what the institution decides to do, what kind of what kind of values the institution has. So yeah, that would be my
Jack's had to do that for a while. I promise it's not just because I know his name. He has
So I've asked a few people in the blockchain community about consensus, and I haven't really gotten a good answer on this. It seems like most networks operate on a 50% plus one basis for consensus, disregarding network partitions and things like that. But there are some institutions that require higher degrees of consensus. Is that a technical limitation? And does Bitcoin, should there be an aspect of Bitcoin that will require higher degrees of consensus before modifying itself? Like, would there be something that you would have to have 80% of the network to agree in order to change it. Is that, you know, like the Senate or other social bodies, like other bodies require higher degree. Is that like a technical limitation? And is that a good feature to have, the 50% plus one?
I'll try to do this real quick, and maybe you'll have a more broad-minded follow-up and go to it very technically. I think it's very risky to equate percentage of consensus in a given blockchain with, say, number of voters in an electorate. What consensus really means is how many CPUs and how much electricity can you purchase. So, right, if you're a Chinese Bitcoin farm, which is all the biggest Bitcoin mining stuff is happening in China now, because there's corruption and they can get electricity cheaper, basically, among other reasons. So whether it's 50% plus one consensus or requires 80% consensus, or there are many schemes that require two-thirds or one-third, all you're really doing is changing the amount of energy and money that a bad actor has to expend in order to control that blockchain. And that's just a dial. Like whether that number happens, whether it's 50% where you cause that number to be $1 billion or something else, doesn't really matter. It's like when you're designing the system, you have to decide where the actual effort required is. Because I can have 5 identities on the blockchain and run 5 nodes, and it's still me controlling them. And I think this gets back to what really matters is the humans behind the system. Like I can look like an entire country on the blockchain. I can look like lots of different people. But actually, I'm just one person with a lot of money and a lot of computers, making it look like I have all this voting power. So you're really just controlling how much to expend in order to do something malicious.
Yeah.
I think, that's, I think actually confirms this case that I was describing about the NSX. So it's not about the number of people who will be there, although of course you need the district officers for procedure and things like that. It's not about the consensus number of people and so on that much as about the identity of people who are willing. So those crypt officers, for example, are selected as being known in the community and trusted in the community and being willing to put their name behind what they're doing and to say, yes, I am doing this, I am testifying to this. So that's a very important element. It's not, it reminds me of that, like we find it, like in Switzerland, we still have today, when someone wants to become a citizen, they start at the local community level, where everyone basically knows, as you were talking, especially if it is like smaller towns and so on, knows the person who wants to become a citizen. And then they gather, all of them, an assembly like the city council, and everyone has the right to say, oh, I know that guy Carl. He actually had done this really bad thing. I do not think that he should become a citizen. And then it goes to the canton level, and then it goes to the state level, and so on. So there is something, to actually think about and try to balance. Is it the number of people and their proposals, or is it also something about identity?
Yeah.
Which, just to comment on that, it raises the point that there's a fundamental contradiction in a lot of these blockchain systems, which is they want to simultaneously create a system that has a lot of trustworthiness and a lot of anonymity. And yet the fundamental element of trustworthiness in most human systems is that people are staking their reputations on what they attest to. And if you have a lot of anonymity, how do you achieve trustworthiness in that system? So I think that contradiction has not really been dealt with in blockchain communities.
That's not true, sorry.
That's
It's actually not true, at least in my opinion, because you had that on some of the darknet markets, where you would be able to give a rating score to the person selling you whatever you'd like it, and the person selling you whatever you'd want also be able to rate you as a buyer. So even in a totally decrypted, decentralized, trustless world, there are still ways to assess.
Very good point. You can establish and preserve reputation within the domain of whatever transactions are being conducted on that blockchain. But your social network, like the president of PCH that Smiljana was talking about, he stands to lose his friends if he messes this up, right? The stakes are higher. But I think that's a very good point. You can accumulate reputation and trust even with pseudonymity. Yeah, thank you.
Yeah, I think I just have another response. Is that to react to what Smiljana was saying in response to Jack's question, because I know him too, is that like when we have these conversations about like, oh well, when it's a community and I know John and so I trust John, right? You know, and I've known John for X number of years, right? This very like fundamental understanding of human relating. Well, there's also this layer of we can never know, and there are bugs in that system too, because I'm thinking of the Me Too movement and the idea that like, oh, well, he was such a nice guy and such a good member of the community, so we thought, right? And then the other thing that I wanted to respond to is when you were talking about like percentages and things like that, which Carl's already responded to. You know, you were using terms like features and things like that, and like specs and stuff like that. And for me, when I hear that, it's like it's politics, right? So it's and because it's politics, it's about power. And like Carl was saying, when it comes down to who has the most money to use the most electricity and the most computing, you know, it's all layered on top of these vestiges of existing power structures, things like colonialism, racism, classism, and all this sort of stuff, right? So it all just always just drills down to that kind of disgusting human layer of the things that we don't like to talk about or think about. You said that you had something else to say, but there was also somebody up here.
And on that note, on the disgusting human layer, I think we're going to have to close it.
Oh, I'm sorry.
Because it is almost 2 o'clock. But I'm sure that Carlos and I might be able to take a few questions immediately after the panel. So thank you all for coming. Again, it's a difficult topic, and I think we all agreed that we were here to kind of learn just as much as we were to discuss some of the technical and social aspects. So thanks again for learning with us, and thanks to